The 2023 Massachusetts amendments to the 2020 National Electrical Code, or NEC, do not prohibit the use of 1/2-inch EMT in commercial applications. Article 358 of the NEC, which covers electrical metallic tubing, states that EMT can be used for conductors in commercial buildings, provided that it meets the requirements of the article. Section 358.12 states that the minimum trade size for EMT is 1/2-inch. However, some jurisdictions may adopt local amendments that require a larger minimum trade size for EMT in certain applications. It is important to check with the local code enforcement authority to determine if there are any local amendments that apply to the use of EMT in commercial applications. In the absence of any local amendments, the 2023 Massachusetts amendments to the 2020 NEC allow the use of 1/2-inch EMT in commercial applications, provided that it meets the requirements of Article 358. While the NEC does not specifically prohibit the use of 1/2-inch EMT in commercial applications, it is important to note that some projects may specify a larger minimum trade size for EMT. This is typically done for reasons such as increased strength or rigidity. It is always a good practice to consult with the project specifications and local code enforcement authority before installing EMT to ensure that all applicable requirements are being met. Firstly, understand the scope of NEC Article 358, which pertains directly to electrical metallic tubing. This article outlines the permitted uses, installation requirements, and specifications for EMT, ensuring electrical systems are both safe and functional. Secondly, examine Section 358.12 closely, as this section explicitly defines the minimum trade size for EMT as 1/2-inch. This establishes a baseline for EMT size, setting the standard unless overridden by more specific requirements or local amendments. Thirdly, recognize the importance of local amendments to the NEC. Jurisdictions often introduce amendments to address unique local conditions or to enhance safety standards beyond the NEC baseline. These amendments can indeed specify larger minimum EMT sizes for certain applications. Fourthly, always consult with the local code enforcement authority. They possess the most accurate and up-to-date information regarding local amendments and interpretations of the NEC, providing clarity and preventing potential code violations. Fifthly, project specifications can also dictate minimum EMT sizes. Engineering designs frequently incorporate specifications that exceed the NEC minimum requirements to ensure greater mechanical strength, accommodate future expansion, or meet specific performance criteria. Sixthly, consider the reasons why a project might specify a larger minimum EMT size. Increased strength and rigidity are common factors, particularly in environments where EMT may be exposed to physical stress or impact. Seventhly, before installation, meticulously review both the project specifications and any local amendments to the NEC. This ensures compliance with all applicable requirements and prevents costly rework due to code violations. Eighthly, understand that compliance with NEC Article 358 is paramount for electrical safety. Proper installation and sizing of EMT protect conductors from physical damage and contribute to the overall reliability of the electrical system. Ninthly, be aware that the NEC is updated periodically, typically every 3 years. Staying current with the latest edition and any relevant amendments is crucial for electrical professionals to ensure their work adheres to the most recent safety standards. Tenthly, consulting with experienced electrical engineers or contractors can provide valuable insights and guidance on complex electrical installations. Their expertise helps ensure compliance with all applicable codes and standards. In Massachusetts, while the state adopts the NEC with amendments, it is crucial to understand how these amendments interact with the base NEC requirements. The NEC provides a foundational set of rules, but state and local jurisdictions often modify these rules to address specific regional needs or concerns. For example, a local amendment might specify that in commercial buildings exceeding a certain square footage, the minimum EMT size must be increased to 3/4 of an inch to enhance the system's mechanical robustness and ensure it can handle potential future expansions without needing complete rewiring. This amendment doesn't negate the NEC allowance of 1/2-inch EMT in general, but it adds a layer of specificity for larger commercial projects within that jurisdiction. To navigate this effectively, first consult the Massachusetts Electrical Code, which incorporates the NEC with state-specific amendments. This document is the primary reference for all electrical installations in the state. Secondly, identify the local jurisdiction where the project is located, as cities and towns may have their own additional amendments or interpretations of the state code. Contact the local electrical inspector or building department to inquire about any local requirements that might affect the EMT sizing. Thirdly, carefully review the project specifications. These documents, prepared by the project's engineers and designers, often include specific requirements for materials and installation methods that go beyond the minimum code requirements. If the project specifications call for 3/4 of an inch EMT as a minimum, that requirement must be followed, regardless of what the base NEC or Massachusetts Electrical Code allows. Fourthly, understand the reasoning behind potential upsizing. Engineers might specify larger EMT sizes to accommodate a greater number of conductors, reduce voltage drop over long distances, or provide better mechanical protection in areas prone to physical damage. These considerations are crucial for ensuring the long-term reliability and safety of the electrical system. Fifthly, be aware that certain types of occupancies might trigger additional requirements. For example, healthcare facilities or data centers often have stricter electrical codes due to the critical nature of their operations. These facilities might require redundant systems, higher levels of surge protection, and more robust wiring methods, potentially leading to the specification of larger EMT sizes. Sixthly, document all code interpretations and decisions. Keep a record of all communications with code officials, any interpretations of the code, and the rationale behind design choices. This documentation can be invaluable in case of future inspections or disputes. Seventhly, participate in continuing education. The electrical code is constantly evolving, and staying up to date with the latest changes is essential for all electrical professionals. Attend courses and seminars offered by industry organizations and code experts to stay informed. Eighthly, collaborate with experienced professionals. Consult with licensed electrical engineers and seasoned contractors who have a deep understanding of the NEC, Massachusetts Electrical Code, and local amendments. Their expertise can help ensure compliance and avoid costly mistakes. Ninthly, consider the impact of future expansions. When designing an electrical system, anticipate potential future needs and plan for expansion. Using larger EMT sizes from the outset can make it easier to add circuits and equipment later without having to replace the entire conduit system. Tenthly, prioritize safety above all else. The electrical code is designed to protect people and property from electrical hazards. Always adhere to the code requirements and take all necessary precautions to ensure a safe and reliable electrical installation. Understanding the interplay between the NEC, state amendments, local ordinances, and project specifications is critical for electrical professionals in Massachusetts. By following these steps and staying informed, they can ensure compliance with all applicable requirements and deliver safe and reliable electrical systems. Remember that the electrical codes and standards are in place to ensure safety and proper functionality. They are not arbitrary rules, but rather guidelines developed through extensive research and experience. Compliance with these codes is not just a legal obligation, but a moral one, as it protects lives and property. Always prioritize safety in every electrical installation and never cut corners or take shortcuts that could compromise the integrity of this system. The NEC provides a comprehensive framework for electrical installations, covering a wide range of topics from wiring methods to overcurrent protection. It is a living document that is constantly updated to reflect the latest technological advancements and safety concerns. The NEC is not intended to be a static set of rules, but rather a dynamic guide that adapts to the changing needs of the electrical industry. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Chapter 1 covers general requirements such as definitions, scope, and administrative provisions. Chapters 2 through 7 cover specific topics such as wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special systems. Chapter 9 contains tables and examples that are used throughout the code. Each article within a chapter addresses a specific topic in more detail. For example, Article 310 covers conductors for general wiring, while Article 430 covers motors, motor circuits, and controllers. Each section within an article provides specific requirements for a particular aspect of the topic. For example, Section 310.15 covers ampacity of conductors, while Section 430.52 covers motor overcurrent protection. The NEC is a complex document, but it is essential for electrical professionals to have a thorough understanding of its contents. The NEC is not intended to be read cover to cover, but rather to be used as a reference guide when needed. When designing or installing an electrical system, it is important to consult the NEC to ensure that all applicable requirements are being met. The NEC is not a substitute for sound engineering judgment. It is important to use common sense and good engineering practices when designing and installing electrical systems. The NEC is a minimum standard, and it is often necessary to exceed the minimum requirements to ensure safe and reliable installation. The NEC is not intended to be a cookbook. It is not possible to simply follow the NEC and expect to have a perfect installation. It is important to understand the principles behind the code requirements and to apply them intelligently. The NEC is not intended to be a static document. It is constantly being revised and updated to reflect the latest technological advancements and safety concerns. It is important to stay current with the latest edition of the NEC and any applicable amendments. The NEC is not intended to be a substitute for experience. It is important to have experience in the electrical industry before attempting to design or install electrical systems. The NEC is a valuable tool, but it is only one tool in the toolbox. It is important to use all of the tools available to ensure a safe and reliable installation. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. Staying current with the latest edition of the NEC is essential for all electrical professionals. The NEC is not just a set of rules, but a guide to safe and reliable electrical installations. By understanding and applying the NEC, electrical professionals can help to protect people and property from electrical hazards. The NEC is a valuable resource that should be consulted whenever electrical work is being performed. The NEC is not a substitute for good judgment, but it is a valuable tool that can help to ensure a safe and reliable installation. The NEC is a complex document, but it is essential for electrical professionals to have a thorough understanding of its contents. The NEC is a minimum standard, and it is often necessary to exceed the minimum requirements to ensure a safe and reliable installation. The NEC is not intended to be a cookbook, but rather a guide that can be used to ensure that electrical installations are safe and reliable. The NEC is a living document that is constantly being revised and updated to reflect the latest technological advancements and safety concerns. Staying current with the latest edition of the NEC is essential for all electrical professionals. The NEC is not a substitute for experience, but it is a valuable tool that can help to ensure that electrical installations are performed safely and correctly. The NEC is a valuable resource that should be consulted whenever electrical work is being performed. Understanding the interplay between the NEC, state amendments, local ordinances, and project specifications is critical for electrical professionals in Massachusetts. By following these steps and staying informed, they can ensure compliance with all applicable requirements and deliver safe and reliable electrical systems.